So we will begin our lessons. This is section 1.1 in your textbook. We're going to be talking about slopes and equations of lines, which is the first topic in our Unit 1A, which is about linear functions. So the first thing we want to talk about is, why do we need to study this? Why are we even doing this? Well, you're business majors, and there are a lot of everyday situations where you have two quantities that are related. For example, if you're talking about a bank account that pays 6% simple interest per year, the interest I that a deposit of P dollars could earn in a year is given by I equals 0.06 times P. And the formula I equals 0.06P describes the relationship between the interest and the amount of money deposited. And if you deposit more money, then of course you would earn more interest. Using this formula, we'll see that if P is equal to $100, then I is going to be $6 because 6% of $100 is $6. And if P is $200, then the amount of interest you would earn in a year would be $12. And those corresponding pairs of numbers can be written as ordered pairs. One of the ordered pairs would be 100, 6, where 100 represents the money and 6 represents the interest. And 200, 12 is, of course, where the $200 deposit earns $12 in interest. And notice that the order is important here, because the first number denotes the variable P, and the second number denotes the value of I, which is the interest. So the horizontal number line, which is the x-axis, represents the first components of the ordered pairs. And the second component is represented by the vertical or y-axis. The point where the number lines cross is the 0 point on both lines, and this point is called the origin. So in our graph grid here, this is the y-axis. This is the x-axis. And this is the origin. And the ordered pairs for that origin would be 0, 0, because that's the 0 point on both axes. As we'll continue our review now, we're going to talk about how you plot pairs. Those ordered pairs are called points. And the way that we do that is, first of all, we're going to plot the ordered pair -2, 4. And to do that, the way we begin is we always start at the origin. And negative says we're going to the left direction because the negative numbers are to the left. We're going to go from the origin backwards 2 spaces, and then we're going to go in the positive direction on your y-axis up 1, 2, 3, 4 spaces. And so that means that the ordered pair -2, 4 is right here. And then similarly, to plot the point 0, 3, we'll again begin at the origin. And because the first coordinate is 0, we're going to stay at the origin. And the second coordinate is 3, so we're going to go up 1, 2, 3. And so this point is 0, 3. And now moving on to the point 2, negative 2. We'll start at the origin and go to the right 2, and then down 2. And here we have the point 2, negative 2. Remembering always that the first coordinate tells us right or left, and the second coordinate tells us up or down. Moving now to negative 5, 0, we start at the origin and go to the left 5 spaces. And then we don't go up or down at all because it says that we're going to move from there 0 spaces. And so this is the point, negative 5, 0. And the point negative 3, negative 4 means we're going to go to the left 3. And then we're going to go down 4. And so here we have the point negative 3, negative 4. And our next point is the point 0, 4. And so similarly to what we did with 0, 3, we're going to go up 1, 2, 3, 4 spaces. And that makes our point on the y-axis. And we have the point 0, 4. Then we have the point 1, 0, which means that we're going to go to the right 1 and stay on the axis. And so that point 1, 0 is right there. And then our final point is 3, 2. And for 3, 2, we will go to the right 3, 1, 2, 3, and up 2, 1, 2, which gives us this point, and that point is 3, 2. Now we need to talk about x and y intercepts. The set of points corresponding to the order pairs of an equation is called the graph of its equation. And the x and the y values of the points where the graph of the equation crosses the axes are called the x-intercept. And the y-intercept. To find the x-intercept, you always choose y to be 0. And to find the y-intercept, you always choose to let x be 0. So in the case of this graph, where x is equal to 0, we have the y-intercept, and the y-intercept in this case is 0, 6. Remember that the y-intercept has the non-zero y value, and the point 8, 0 is the x-intercept because the x value is the non-zero component. To find intercepts from an equation algebraically, we have the equation y equals negative x plus 2. And for the x-intercept, we'll let y equal 0. And then we'll add x to both sides so that we get the x variable by itself. And we see that x is equal to 2. So the x-intercept is 2, 0. And for the y-intercept, we will let x equal 0. And of course, the opposite of 0 is still 0. And we have y equals 2. And so our y-intercept is 0, 2. So even though it crosses the x and the y-axis at the values of 2, the x-intercept looks very different from the y-intercept because the 2 comes first in the x-intercept and it comes in the second position for the y-intercept. One of the most important characteristics that we're going to be talking about when we talk about functions, and especially important as we go into calculus next semester, the most important characteristic of a straight line is called its slope. That number represents the rate of change of the line or the slant of the line. The change in the x values here means that we're going from negative 3, 5 to positive 2, negative 4. And so the change in the x values is this distance. And when you go from negative 3 to positive 2, we say that the change in x, that triangle means the change in, it's called a delta. We say that the change in x is 2 minus negative 3. You always start at your ending point and subtract your beginning point. And then for the change in the y values, we're talking about going from negative 3, 5 to positive 2, negative 4. And so we're talking about the change in the vertical direction. And again, you always start with where you end. So we're going to start with the negative 4 and subtract the positive 5, which gives us negative 9. And so we say that delta y is equal to negative 4 minus 5. So just as a quick recap, in mathematical symbols, the change in x is denoted by delta x, and the change in y is denoted by delta y. Delta is the Greek letter D, which stands for difference. So we have a formula for the slope of a line that's based on delta y and delta x. And the formula is given here. The slope of a non-vertical line is defined as the vertical change, which sometimes we call the rise, over the horizontal change, which we sometimes call the run, as one travels along the line. In symbols, using the two different points here, x1, y1, and x2, y2, the slope is given by, once again, the change in y over the change in x. Remember, y is always on top, or delta y over delta x. And that means that the coordinates of your points need to stay together. And the y value of those points needs to go on top. And so by this definition, the slope from the previous slide would be, let's see, the change in y was negative 4 minus 5, and the change in x was positive 2 minus negative 3, because our points were 2, negative 4, and negative 3, 5. And so notice here that the 2, negative 4 was on the front end, and the negative 3, 5 was on the other end. And our slope, which is the change in y over the change in x, was negative, sorry about that, negative 5 over, I'm sorry, negative 9 over positive 5. Now, it would have been equally correct here, just so that you're aware. Would have been equally correct to have begun with negative 3, 5. And had the second ordered pair be the 2, negative 4. because we would have wound up in that case with 5 minus negative 4 is positive 9, over negative 3 minus 2 is negative 5. But both negative 9 over 5 and 9 over negative 5 are still the same slope. It's negative 9 over 5. So it isn't the order of subtracting the pairs that's nearly as important as realizing that you need to keep the y values on top, the x values on the bottom, and your points coordinates need to stay together. So we're going to find the slope through each pair of points, and the first one we have here is 7, 6. And the second one is negative 4, 5. And so to find the slope, m is the change in y over the change in x, which is the difference of the y values over the difference in the x values. And so we can do it by saying that the first point is 7, 6. 7 goes on the bottom, 6 goes on top. The second point is negative 4, 5. Negative 4 goes in the bottom. 5 goes in the top. And we find that the slope is 6 minus 5 is 1. 7 minus negative 4 is 7 plus 4, or 11, and the slope is 1 over 11. Or it's just as correct, once again, to begin with the negative 4, 5, and your second point is 7, 6, which would give us 5 minus 6 is negative 1, and negative 4 minus 7 is negative 11, which is still 1 over 11. Either way is fine. The key is that you need to keep your points together, because if you don't, this is what could happen. Notice that I've mixed up the coordinates of my points and they're no longer together. And when I do that, 6 minus 5 is 1. Negative 4 minus 7 is negative 11, which is equal to negative 1 over 11, which is not correct. And the problem is that you're going to get the opposite sign from the sign that you need. Your actual numerical differences will remain the same if you neglect the sign, but if the slope should have been positive and you do it this way, you're going to wind up with the slope being negative. So be very cautious about that. Do not do this. This is very, very important. Do not do that. Always keep the coordinates of your points together on each end of the fraction. And so this is just a summary of the way that I found those. So for the rest of this, I'm just going to do it whichever way that comes to mind first. But remember, keep your points together. Don't try to remember a formula for slope. Remember the process. The slope is the change in y over the change in x. And the change simply is asking you to find a difference. And if you'll just remember that, and then keep your points coordinates together. So we have negative 3 minus negative 3, which is 0. And 5 minus negative 2 is 7. And so our slope here is actually 0. Again, same process. Just remember that slope is the change in the y values divided by the change in the x values. So rather than memorize a formula, draw a fraction line and make sure you're subtracting both in the numerator and the denominator. Take the coordinates of one of the points, and notice here I deliberately switched the order up, but that's not going to matter because the coordinates of my points are together. And this time I have 3 minus negative 4 is 3 plus 4, or 7. And 2 minus 2 is 0. And this is a very important point here. I want to emphasize this to you. Big caution, we cannot have division by 0. By definition, division by 0 is undefined. Therefore, this slope is undefined. And notice here, this is very, very important to me. I will remind you of this if you make the mistake. Do not ever use the phrase no slope. You need to specify whether that slope is 0 or undefined, because no could actually mean either one. No meaning none, which is 0, or no slope could mean that it doesn't slant, which is what an undefined slope is. An undefined slope is a vertical line. All rise, no run. Whereas a horizontal slope, or a 0 slope, is a horizontal line. All run, no rise. So here's a picture of slopes, and I want you to kind of keep these ideas in mind. Remember that undefined slope is what the y-axis has, because the y-axis is a vertical line. So this slope is undefined. Zero slope is the slope of the x-axis. Notice that lines that rise as they go from left to right have positive slopes. And by the same token, lines that fall as they go from left to right have negative slopes. For the lines that I just looked at, m equals 1 means that you go up 1 and over 1 to get the other points on the line. This is a shallower slope than the slope of the line, m equals 4. This is a steeper slope. Whereas this line, with a slope of 1 over 5, is a shallower slope, or less steep. So less steep lines will be closer to the x-axis, and more steep lines will be closer to the y-axis. And the same thing applies to your negative slopes. -3 is a negative slope, but it is a steeper slope than m equals -1, and m equals -1/3 is a less steep slope. So fractional slopes values between 0 and 1 are less steep. And fraction or slopes that are improper fractions, or in other words, values between 1 and 0, are more steep. Improper fractions, remember, is where the numerator is larger than the denominator, whereas a proper fraction is where the denominator is larger than the numerator. So this is just a summary of the relationship about slope. You need those basic concepts much more than you need skill in applying a formula. So this is your turn, and I'm not going to do this problem for you. The answer is in your textbook. It's on the problem itself is on page 4, but the your turn problem here is actually answered at the end of the section just before the review exercises, so you can find the answer to this one in the book. If you have questions, we'll go over those questions in class. Now we need to talk some more about the equation of a line. An equation of two first-degree variables, that should say variables, not equations. Equation of two first-degree variables, such as 2x minus 4y equals 8, has a line as its graph, and so it's called a linear equation. The equation as it's written here is referred to as the standard form for the equation of a line. The standard form is often written as ax plus by is equal to C. And notice those are capital A, B, and C. You don't use lowercase letters. And A, B, and C are all real numbers. And those real numbers are called the coefficients, and C is actually referred to as the constant. If a line has the slope of m and a y-intercept of 0 lowercase b, notice the difference here, and xy is any other point on that line, then from the formula for slope, here's what we would have. Here's our point, xy. And 0b is the other point. And algebraically, we know that we can actually just forget about the 0 because it doesn't change anything. And so what we have from this is that the slope is equal to y minus b over x. And if I multiply both sides of this equation by x, then these x's cancel out. And I have mx is equal to y minus b, or equivalently, y minus b is equal to mx. And then if I add b to both sides, I have y equals mx plus b. So once again, this is equal to m equals y minus b over x, and y minus b over x. In order to solve this for y, we'll multiply both sides by m. I'm sorry, not by m. By x. And so that leaves us with y minus b equals mx. Add b to both sides. And that gives us y equals mx plus b. I don't expect you to know how to derive that formula, but I want you to understand where it came from. And we call this the slope intercept. Form of the line, with y being the slope, y m being the slope, and b is the y value of the y-intercept. And that's why it's called the slope-intercept form of the line. This is the most common form for writing the equation of a line. And on a graphing calculator, we're going to need to be able to do this. Even if the equation is given in a different form, we need to have the equation in the slope-intercept form. So a little practice here. Find an equation in the slope-intercept form. That's y equals mx plus b. Through the point 0, 3, which tells us that b is equal to 3. with the slope, which we know is m, is 3/4. And so our equation, we'll plug in 3/4 for m, and 3 for b, and we'll have y equals 3/4 times x plus 3. Now in this case, we're also going to be using y equals mx plus b. But we have an x and a y intercept. That means we'll know right off the bat the value of b because we do have the y-intercept, but we don't have the slope. So what we'll do is we'll take these 2 points, 0, 2, 7, 0, and the slope is 2 over -7. We'll just bring the negative sign out front because it can go with the numerator or the denominator, either one, still the same thing. And we have the slope is equal to -2/7. And we have that b is equal to 2. And so y equals the slope m times x plus b. If you don't have the slope, but you have the points, you can always find the slope. This is your turn. I want you to do the same thing that I just did. So pause the video here and try to work it. And you've got an x-intercept of -4 and a y-intercept of 0, 6. So find your slope, identify your y-intercept, and use your form y equals mx plus b. In example 3, we have the equation of the line, but it's in standard form. And we would like to have it in the form of y equals mx plus b. So the easiest way to do this is to employ a little bit of algebra. Take what we're given, and since we want to isolate the y, what we need to do first is we need to subtract 3x from both sides. That'll get rid of it on the left-hand side and leave us with -4 times y. And since we want it with the x term first and the value of b last, then we're going to write the -3x first plus 12. We're still not quite finished because we don't have y by itself. We still have the -4. And so in order to undo the multiplying by -4, then we're going to divide -4, but we're going to divide every term by -4. So that eliminates the -4 in front of the y, and we have our goal now. Y equals -3 over -4 is 3 over 4 times x, and then 12 divided by -4 is -3, and you can write that as y equals 3/4 x plus -3, or you can just realize that it is 3x minus 3/4 x minus 3. Either way is fine. So solve your standard form equation for y using your algebra. This is also going to be an equation written in slope-intercept form. Some of you may have done ways other than what I'm going to show you, but remember that I've told you that I will show you the easiest way that I know to do everything. So here I'm going to write an equation that passes through the point 3, -7, and has slope of 5/4. Now I've got my slope, but I don't have the y-intercept. What I'm going to do in that case is I'm going to take my slope-intercept form and I'm going to plug in what I know. I know that m is 5/4. But I also know that x is equal to 3. And I know that y is equal to -7. So now filling in the rest of the equation, the only thing I don't know is b. I need to find b. And that's a simple matter of some arithmetic and a little bit of algebra. So the first thing I'm going to do is I'm going to multiply 5/4 times 3. 5 times 3 is 15 over 4 plus b. Y was equal to -7. I need to subtract 15 over 4 from both sides. That will eliminate it from in front of the b. So I have that b is equal to -7 minus 15 over 4. Now at this point you have some choices. You can do the arithmetic or you can use your calculator. I'm going to do the arithmetic just as a reminder of how to do it. In order to do this subtraction, I need to have a common denominator. And in order to have that common denominator of 4, I need to multiply both the 7 and the 4, or 7 and the 1 by 4. Seven times 4 is 28. So that tells me that b is equal to -28 minus 15 is -43. Over 4. Or if you choose to use your calculator and do the fraction arithmetic and change it to a decimal, I have no problem with that, because in business and in real life, most of the time we don't deal with fractions. Most of the time we will deal with the decimal, as long as we've got a decimal that is a terminating decimal. And if we're dealing with a real situation, we'll still convert to a decimal and round to whatever seems appropriate. So that means your equation here is going to be y equals 5/4 times x plus -43 over 4 or it's perfectly okay to say that the equation is y is equal to 1.25, because 5/4 is 1.25, times x minus 10.75. Now, in my math lab, it's going to require you probably to do this. But on a test, I'm going to be perfectly okay if you do that. Because if we're going to find the equation, chances are we're going to need to graph it at some point or substitute values into it. And if we're going to do that, the decimal form of the equation is just fine. It works really well. Find the slope of the line whose equation is 8x plus 3y equals 5. This is your turn. So you need to do this problem. Remember, what you're doing is you're going to set this equation to where it's equal to y. We want it in the form y equals mx plus b, and you need to use your algebra skills to do that. Slope-intercept form if all you're given is 2 points. Remember, slope-intercept form is y equals mx plus b. That means one of the very first things that we're going to need to do is find m. And in order to find m, remember that it's just the difference of the y's and the x's. Either point can come first. So 4 plus 2 is 6. 5 plus 10 is 15. It's okay with me if you want to put that in lowest terms. It's okay to work with it the way that it is. Dividing numerator and denominator by 3 or using your calculator. 6 over 5 is or 15 is the same as 2/5. You should know how to use your calculator to turn 6 divided by 15 into 2/5. So if you want to do it with your calculator, that's how you do it. So we have that the slope is 2/5. We also have our choice of x and y values. I'm going to choose the first point, which gives me that x is equal to 5, y is equal to 4, and so y equals mx plus b gives me my slope is 2/5. My point is 5, 4, and so B then, you can actually do this all on your calculator too if you want. And doing the math and turning it into a fraction is optional. Basically, you're going to wind up with 4 minus 2, and so B is going to be 2. So do the calculator or do the arithmetic, whichever you wish. And that gives us our final answer that we're looking for. Y equals 2/5 x plus 2. And again, you have your turn. This is your turn 4. Use the same method that I used, review if you need to, and find the equation of the line through the point 2,9 and 5,3. Make sure it's in slope-intercept form. If you need to find an equation given 2 points, we're always going to do it this way. So we're going to use y equals mx plus b. First thing we need is m. -4 minus -4 is 0. 8 minus -2 is 10. Our slope is 0. We'll need to find b. We know that our slope is 0. Choosing the first point, we have that b is equal to, because 0 times 8 is 0, b is equal to -4. And therefore, the equation of our line is y equals 0 times x minus 4, which is the same thing as y equals -4, which is a horizontal line. And notice that it wouldn't have mattered if I had opted instead to use -2, -4, because I would have still had -4 over here, and the -2 would still have turned out to be 0. So it doesn't matter which point you use. So now we need to talk a little bit about how this is going to work. If you plot the 2 points and connect them with a straight line, you can verify that the equation y equals -4 is exactly what you have, because here's your y-intercept at the point 0, -4, and the line with 0 slope that goes through that point, as well as those other 2 points, is that line. Every horizontal line has a slope of 0 and an equation of the form y equals k, where k is the y value of all of the ordered pairs. This is an example of how finding an equation that actually turns out to be a vertical line. We'll follow the same process. y equals mx plus b. First thing we need to do is find m. Use either point you want to be the first one. Our slope here is undefined. So because our slope is undefined, using y equals mx plus b really isn't going to serve us too well. So when you get an undefined slope, and I'm going to verify this by showing you the plotted points. If you plot those 2 points, you're going to see that you get a vertical line, but your vertical line has the same x values everywhere, including the x-intercept 4, 0. So this is a vertical line. And every vertical line has an undefined, again, don't use that word no. It's an undefined slope. Its equation is the form x equals k, where k is the x value for all the ordered pairs. This is another your turn problem, similar to the one that we just did, or several of the ones that we just did actually. Says it's going to pass through the point (4, 5), and it's parallel to the line 3x minus 6y equals 7. The fact that it's parallel means it has the same slope. So your first step here is going to be to find the slope of this equation. And then use that slope with the point 4, 5 to find your equation. And again, if you have questions, I'll be glad to answer those in class. So this is a summary of everything that we have up to this point. Slope of horizontal and vertical lines. The slope of a horizontal line is 0. The slope of a vertical line is undefined. We will not ever use the term no slope. Equations of line, the ones that we're going to use, are going to be y equals mx plus b, which is the slope-intercept form of the line. We'll know that a vertical line is always x equals some number, and a horizontal line is always y equals some number. And even though I left it in here, we will not use, and you notice that I did not include any examples of doing the point slope form for a line, because it is a lot more arithmetic, a lot more algebra, and in the long run, it is more likely to lead you to make a mistake, such as dropping a sign or multiplying wrong, than it is just to use y equals mx plus b. So we're going to wind up with an example of how this actually refers to anything in the real world. In recent years, the percentage of U.S. population at age 18 or older who smoke decreased, that's an important word, decreased, at a roughly constant rate, from 20.9% in 2005 to 18.1% in 2012. And we have a citation so that you know this actually does come from a real set of data. And we want to find a linear equation that models the percentage of this population. Now, one thing I want to tell you, when you're doing word problems, don't expect to get it in 2 seconds. I don't get it in 2 seconds. And I've been at this a lot longer than you have. Always read your problem through. Make sure you understand what the problem says. Read it a second or a third time if you need to. And think about what you know from reading the problem. So what I know from reading the problem is that, again, the percentage decreased. If the percentage decreased, that means it goes down. Thinking about the fact that it goes down at a roughly constant rate makes me think about linear equations, and this linear equation will have a negative slope or slant because it is decreasing. The next thing I want to think about is how am I going to get any points for this? Well, the percentage decreased over the course of the years. So the amount of actual decrease is going to depend on what year it is. That tells me that this is the x values of my points, and that the percentage is my y values. And so this is giving me 2 points. From those 2 points, I can find the slope of this equation. You can use your calculator for this. And 2005 minus 2012 is -7. So I now know that the slope is -0.4. And I'll take my first point to use for my x and y. So substituting in, I have 20.9 is equal to negative 0.4 times 2005 plus b. Negative 0.4 times 2005 is negative 802. And when I add 802 plus 20.9, I get 822.9. So my equation in slope-intercept form is y, which is the percentage, is equal to negative 0.4 times x, which is the year, plus 822.9 and that should be the equation that models the population. So what does that mean? Well, in function form, which is what we're going to talk about in the next section, we would say that y represents the percentage, so I'm going to call that the percentage, P, is equal to negative 0.4 times, since the year is actually time, I'm going to call that T, plus 822.9 percentage of the U.S. population age 18 or older, in year T, who smoke. So the important point here is that this is the equation. But in a realistic problem, and that's what this is an application problem, you don't want just the equation. You want the linear model which is the equation plus explanation of what the variables means. Including units. Units of measure. In this case, it's percentage in year. Okay? Communication is one of the things that I really, really will focus on in this course. You are business majors. You have to learn to communicate verbally and in writing. Nobody, when you actually get a job, is going to ask you to solve 15 or 20 algebra problems and tell them what x equals. They don't care what x equals, just like you don't care what x equals. What they want to know is the answer to a question. And so this entire course, starting now, is going to focus on answering a real question that someone wants the answer to. Be sure that you understand that you are expected to write out complete sentences for your answers. So what that equation gives us is nothing. It's just a bunch of math jumble. What we need to do is we need to turn that equation into an explanation of what the answer to the question is. So the first thing that I'm going to do in this case is I'm going to change the equation into something that looks more like an explanation. Since P is the percentage, that was the Y value, that I'm going to use P, capital P, for percentage rather than using Y. And I'm going to use T because T actually represents what year it is, that's time. So the equation actually should be P equals negative 0.4 times T plus 822.9 percentage of the U.S. population age 18 or older in year T who smoke. Communication is the key. You are a business major. You are not going to be asked to solve a bunch of algebra equations and tell someone what x equals. You don't care what x equals. They don't either. They want the answer to the question. You need to be able to answer those questions in complete sentences with subjects and verbs and good grammar and correct spelling. That's going to be the one of 2 or 3 top priorities for this course, is that you learn to solve applications problems and answer questions that have some meaning to someone. A linear model, and that's what this is, it's a linear model. The long phrase is linear mathematical model. The linear model here, you need to understand, is the equation plus an explanation of what the variables mean with the units of measure on those variables. T represents time, which is the year, the specific year. P represents the percentage in that year. In the next section, we'll learn about function notation, and this would actually be written in function notation as P of T. So now that we have that equation, one objective of Healthy People 2020, a campaign of the U.S. Department of Health and Human Services, is to reduce the percentage of U.S. adults that smoke smoke to 12% or less by the year 2020. If the decline in smoking continues at this same rate, will they meet that objective? Well, remembering that the percentage in year T is negative 0.4 times the year plus 822.9 the percentage in year 2020, they want it to be 12% or less. We need to find out what this equation predicts for t equals 2020. That means P of 2020 is negative 0.4 times 2020 plus 822.9. So I used my calculator and I came up with 14.9. That means in 2020, the percentage will be 14.9%. Of the population that smokes. And then the answer to the question, they will not reach their objective. In 2020. Now, we could solve the problem and find out when they will reach their objective, but the answer to this question was, in 2020, the percentage will be 14.9%, which is more than 12%, and therefore in 2020, they will not have reached their objective. Be sure you explain your answers. You can also use the graphing calculator to fit an equation to this information and find the linear equation for 2 points, and use that information to create a table of values on the calculator and determine what the rate will be in 2020. The way that we're going to do this, and we're going to do this again later, which is why I'm introducing it now, is you're first going to press your stat button on your calculator, and you're going to choose to edit the data, which means you're just going to hit enter. And then you're going to type the 2 pairs of points into the calculator list as shown. Notice that this is the first set of points. And this is the second point. Then you're going to press stat again. And you're going to choose Calc, which is the middle menu. That I didn't use the entire year. I did something called scaling the data, which means that instead of 2005, I simply put in 5. And in 2012, I simply put in 12. Then you're going to choose the fourth option on that page, LINREG, by pressing the number 4. And your calculator screen will look like this. We need to supply the calculator with 3 pieces of information. We need to tell it where the list that contains the X values for the ordered pairs is. Separate that with a comma, which is above the number 7 key. And then we need to tell it where the list is that contains the Y values for the ordered pairs. And then you're going to need to put in another comma, because the comma separates the pieces of information. The last thing is we're going to tell it where the location is that we want to have the equation stored. And we want to store it at Y1 on your Y equals menu. The way that we tell it that is the location of the X values is in list 1, or L1, so you press your second and your number 1 key. Location of the Y values is in L2, so you press your second and your number 2 key. And then to get Y1, you press the VARS key, which is right below your arrow keys. You use the right arrow to go to the Y variables on that window, and then you press enter 3 times. And then I'll show you the steps on the calculator screen. So for that reason, so we're sitting here, you press the second key, then you press the number 1 key, and this is what you see. Then you press your second key again, and you press your number 7 key. That will give you the comma. Then you press your second key, and you press your number 2 key, and you get this, then another comma, second, number 7. Then you press your variables key, which brings you here, right arrow to your Y values, which keeps you here. Then first enter chooses function, which is this option. The second enter chooses Y1, which puts it on your screen here. The third enter takes you to the information for your equation. Now in this particular case, I want you to notice when I get here, I didn't get 822.9, I got 22.9. But this equation will still work. And if you press your Y equals key, you'll see the equation. And then you press the second window key, will help you set up your table of values. You want your table of values to ask. You don't want it to be auto. You want that to be ask. Everything else stays the same. Doesn't matter where the table starts, leave dependent on auto, but you want to change the independent to ask. We're going to use this procedure a lot this semester, so you want to review this probably later, which is why I made these slides, and I'll also review it in class. The last thing you're going to do is press second graph to actually see the table. And since I use the number of years after 2000 for the X values, then that number would be 20 for the year 2020. And as soon as you enter the 20 and press enter, you'll see that the percentage is 14.9%. Now again, this would work just fine if you use 2005 and 2012 for your x values. Your equation would come up exactly the way that we did it algebraically, but you still get the same answer. The process that I used here is something called scaling the data. It isn't critical for linear data, but it will be important later on when we do modeling for something that is not linear. So our last topic is graphing. We want to graph the line y equals -3/2 x plus 6. This is another of the very important topics we're going to cover here. We need to learn to graph. That's another top 3 concept for this course, is learning to graph equations with and without a calculator. So in order to graph this equation, we know from what we've already done, this graph is going to cross the y-axis at the point 0.06. So we need to plot the point 0.06. And there it is. The slope of this line is negative, which tells us it's going to go downhill. And we can use it either as -3 over 2 or 3 over -2. You can actually do that either way. And so from this point, if I go down 3 and right 2, it brings me to this point. Now it just happens that that point is 2, 3, but that isn't really important. What is important is that that's how I got that point. I can also do it by going up 3 and left 2, which would put me here. And now I'll graph my line. And looks like I messed up a little bit, so let's use the eraser. And so this graph is the graph of the line y equals -3/2 x plus 6. You always want to put your equation on your graph. This is the x-axis, and this is the y-axis. you always want to use a ruler. It isn't important if it has number markings on it, but the fact that it has a straight edge. Okay, so you want a straight edge. One of the pieces of equipment you're going to want for this class is something that you can use as a straight edge. Now, if your graph is small, your driver's license or credit card or your student ID make a perfectly good straight edge. But it probably wouldn't hurt if you had a little short 6-inch straight edge, such as the one that comes in the student planners. If you don't have a student planner, let me know. I can get you one. Now, we also need to know how to graph on the calculator. So, in order to graph it on the calculator, we press y equals and enter the equation into y1, which is what I've done here. You want to be sure that you put fractions in parentheses. If you have the TI-83. If you have one of the newer TI-84s, it actually has fractions that look like fractions. But if you have the older TI-83, then you'll have to use your parentheses around your fractions. Then you're going to press your zoom, which is here, and you're going to choose option 6 in this case because we just want a regular standard -10 to 10 in both x and y directions graph. And when you hit that number 6, you'll actually get the graph that you see here. So here's our last example. Table on the left lists the average annual cost in dollars of tuition and fees at a public 4-year college for the selected years. We want to plot the cost of public colleges by letting t correspond to the year 2000. And then find out, are the data exactly linear? And could they be approximated by a linear equation? So this is the set of data that we have. If you've had prob and stats, you already know how to do this. If you haven't had prob and stats, I will be demonstrating it in class and in another recorded lecture that walks through the steps on the calculator. This is simply for review. What you're going to do is you're going to press your stat button, and then you're going to choose enter, which makes the choice edit, and you're going to enter the data that you have from that list into list 1 and list 2. The years are the x values, the tuition amounts are the y values. You're going to press second y equals, change the screen as necessary to match this one here. Second y equals is your stat plots. So you're going to choose option number 1, which is plot number 1. It's probably in the off position. You need to turn it on. You want to always keep it on this option. We are not going to use any of the others, just that one. We're always going to use list 1 for our x values and list 2 for our y values. And you're always going to keep this one on the first option because it's the easiest one to see. You would press zoom and select number 9, zoom stat, and press enter. When you do that, you'll see this statistics plot. Is the data approximately linear? Well, perfectly linear, no. Sort of follows a straight line, yeah. So we're going to begin to calculate the equation by pressing stat right arrow to the Calc menu, choose number 4, linear regression. We've done this before. This is, again, just a review. Press 2nd and 1 to get your L1, then the comma. Remember, that's above the number 7 key. And then 2nd and 2 to get your list 2, and then another comma. Then you're going to press the vars key, which takes you here. You're going to right arrow to the Y vars key, which is here. You're going to press enter twice. First time to choose function, second time to paste it onto the screen. Then you press enter one more time. This is what you see. You don't need to worry about this or this. If you don't see it, that's fine, because I don't really care if you see those or not. This is not a statistics class. We're not going to do a lot of analysis of modeling. But you press the graph key, and you see that that does fit a line rather well. Now, the thing that I did not do, I'm going to tell you this up now, right up front, I did not align the data so that t equals 0 corresponds to 2000. But because it's a linear equation, I'm okay with what I have, because I have the right equation and it did fit the data. So this is the summary of everything that you need to know. The only thing you don't need to bother with knowing is this. We're not going to worry about point slope formulas. But you need to know these things. You will have a formula sheet on the exam if you need it, but this is just a summary of what we've looked at in this section. I will be doing another recording of the problems where I use the calculator extensively, because you need to actually see the work on the calculator when I do that. If you have questions, please post your questions right here in your notes folder, and I'll try to answer them as quickly as possible. If it's a question that you're comfortable asking in front of the whole class, go on over to the discussions board and ask it there, and I'll answer it for everyone. See you on Wednesday.